podcast listeners. Hope you are doing great. I'm here today to talk about essential insights on building ML pipelines, the different components that belong to a functional and an efficient in such a pipeline, and also the importance of ML monitoring. But don't worry, I won't be giving a monologue, but instead have this discussion with Sage Elliott, who I have here today. How are you, Sage?
I'm doing good. Thank you for the intro. How are you doing?
So far, so good. Very excited to have this conversation with you. I have some interesting questions ready for you to dig in.
Awesome. Yeah, I'm always excited to talk about ML pipelines or ML in production. Really, it's kind of been
Yeah,
my background for a while. So
awesome, great. Okay, so maybe before we get started, how about you give like a brief introduction about yourself? You mentioned that you have a lot of experience in ML in production, so yeah.
sure. Yeah, my name is Sage Elliott. Like you mentioned, I'm in Seattle, Washington, which is where I'm recording this from right now. I've lived here for like 9 years. Currently, I'm working to make AI and ML pipelines better at Union.ai. You can check out everything we're doing over there. We're built on top of and maintain one of the most popular open source data and ML orchestration platforms called Flyte, Flyte. You can check that out too at flyte.org or find the GitHub. And we always appreciate GitHub stars too. And then before working here, I've worked a lot with computer vision and ML monitoring, and basically helping people at different companies that I've worked at get models in production and create better models often with that production data. So I'm sure we'll dive into this a little bit later,
Oh
but
yeah.
talking about what does that look like and how do you kind of build somewhat of an infrastructure to make that happen, and what does ML monitoring look like? How do you look at a model once it's in production and keep updating it to kind of maintain the results that you want from it?
Nice. Yeah, yeah, that's a very rich background, I would say. So yeah, let's talk about ML pipeline. So I always like to start with basics, just so that I can cover, or if anybody in the audience have any questions around that. So what are the different components that tie up together in a general machine learning pipeline? And if you can talk about, from basic ML application to the generative AI applications, that would be really great.
Sure. And yeah, I'll list off probably some of the general stuff that you're going to see in most of the pipelines. The pipelines do vary, between use case and company. So potentially I might be missing something that you're looking for in your pipeline, or maybe I've talked about too many things and you don't have all these things in your pipeline. That's fine. They all kind of look a little bit different. But I'm going to go through some of the most common things that you probably see. And yeah, I mean, a ML pipeline is usually kind of a structured sequence of tasks to process and like usually develop and deploy and then continue to maintain that machine learning model in
Mhm.
production. And I like to think of it as a ML lifecycle. You don't just deploy a model once usually and then you're done with it. You kind of want to have this constant feedback loop that we're going to talk about. But I kind of like to think of it as a circle. So I'm going to
Mm.
list some stuff like starting with data and then model training. That model is in production, you're monitoring it, and then typically you're collecting new data from production and then kind of restarting the loop again. So I like to think of this as a bit of a life cycle.
Mm, mm,
And it should make, when you're building out the pipeline, it should make the end-to-end workflow of building your whole AI system or machine learning system easier for like anyone on your team or who should be running this to run. From the data collection, model deployment, and then monitoring piece, you kind of want to think about how do you make this not just how you structure those tasks, but also making them reliable and running consistent and oftentimes efficiently as well. So you might have like we can dive a little bit into that probably a little bit later, but it should be efficient for like your team to rerun things, but also for the compute that you're running on. And so the core of most of the ML pipelines are often kind of tied together with some sort of AI orchestration or orchestration platform or tool, and then it kind of orchestrates the libraries and compute needed to perform all these tasks that we're going to talk about together. And then usually, if you have like a modern tool, you'll get stuff that also helps make it like more reliable and efficient as you can continue to build it.
I was just curious, like, what are the orchestration tools that you prefer to use? And
Well,
would it differ from use case to use case?
yeah, well, I'm pretty biased since I work at an orchestration company or a company that maintains the orchestration tool,
Uh-huh.
Flyte, Flyte. So that's one I would
Mm-hmm.
definitely recommend checking out. I think we have a lot of the really modern features that we'll, again, probably dive a little bit more into later. But things like built-in features like caching or task level containerization. So, you might already know, like there's parts of your pipeline where you're collecting data and downloading data sets, doing pre-processing. Then you might have the actual model training itself. And when you're model training, depending on your model, you might need a GPU for that. A lot of the
Mm-hmm.
older type of orchestration tools, you might have had like a monolithic workflow with all these tasks kind of tied together with one compute instance. So you'd be running all this other tasks on a GPU instance, even if you weren't using it all the time. So being able to kind of like containerize every single task to only run on the compute that's needed is, could be a big driver and efficiency for your organization. That's just like one example, but there's a lot of other stuff that we'll probably go in a little bit later, more into like caching and some other kind of best practices to think about when you're implementing a workflow or a pipeline.
Okay, got it, got
But
it.
going back to your original question, I think what are all the steps? So let's say we've kind of chosen some sort of use case to build an ML application for. Typically, you're going to have something like data collection, potentially data pre-processing, feature engineering, where you're taking features from that data set
Mm-hmm.
and deciding what's actually going to be useful for your machine learning model. You might have data annotation. A common use case that you might have seen for that is if you're doing something like computer vision, you might be drawing bounding boxes around a specific animal or something that you want to predict where it is in the image. Obviously, you use annotation and tabular data and in text as well. And then you also might want to do like data validation and exploratory analysis, making sure that the data looks like it should after you've pre-processed it. Also, you should just get to know your data a little bit before you're probably training a model and make
Yeah.
some assumptions about like what type of model you should choose for it. And often these might be broken out into kind of two different pipelines potentially. Again, it depends on the company, but you might have a whole data pipeline, data engineering side to your org, and then you might have a more machine learning or model focused side to your org, and then you could get into the model selection, model training, model evaluation, and validation. With that, you'll also usually want some form of experiment tracking where you're kind of looking at the data set that came into a machine learning model and the model that came out of that, because often you don't just train it once, like you might have to train it several times to get the results you want. And then, like I talked about, once you have it deployed, which is kind of the next step, model deployment, then you'll also probably want some form of ML model monitoring,
Mm-hmm.
and then kind of tie that whole loop back together again. And then you
Yeah.
could also do something on deployment side called shadow deployment, which is a common way to evaluate one or multiple models in on production data
Mm-hmm.
without it actually being out making those decisions and potentially causing issues for customers. So shadow deployment, it's like you have a model, it's getting the same data as your current model in production. You can see how
Ah.
it's making prediction, but maybe you didn't actually deploy it yet to the user because you want to verify that it's going to run the
Right.
way you think it is. And then, like I
Nice.
mentioned, you usually have some sort of framework, or maybe it's even just processes kind of in place, tying all those things together with your team. And you should be able to hopefully kind of run this whole pipeline pretty easily, because most of the time you're going to be kind of doing that life cycle probably quite a bit in your AI application's lifespan.
Mm-hmm. Got it. Awesome. So you mentioned all the components and the steps to follow. When it comes to everything is done and you are ready to push that model into production. So w when you have the pipeline built, what part of this pipeline is the most intense to build?
Yeah, that's a great question. And I think I also kind of forgot to maybe tack on to some of the differences between a Gen AI workflow
Oh
versus a
yeah,
traditional ML
yeah.
workflow. That's my bad. I was like, oh wait, I feel like I was missing something. Um, and I'll just briefly say, like, most of the same stuff, like the data collection,
Mm,
model training, etc. For some search recommendation ML models and Gen AI, like everyone is using large language models in production right now. You might often also have like a database or a vector database where you're storing other information that that
Mm-hmm.
model can use. So you might have already heard of something called RAG, RAG, which stands for Retrieval Augmented Generation. I feel like I always mess it up when I try to think what it stands for. Pretty sure that's what it stands for. And that's a technique for usually bringing in new data or data that you have stored somewhere to your large language model to kind of enhance the knowledge. So you have a
Mm-hmm.
user query something, it finds relevant data in a usually a vector database, brings that information into the LLM, and then it can use that information to structure to generate an answer based on that data that it pulled from that database. And it
Mm-hmm.
also allows LLMs to like cite sources as well. So if you've been using anything like Copilot, you'll probably see that I don't know how it works in the back, but I assume they have a RAG system scraping the web and then citing you back to specific resources sometimes, which is pretty cool. So you can
Okay.
actually say this looks relevant. I'm going to click in and actually read the docs now and verify that's correct, or I want to dive deeper. Also for Gen AI, and again, I know we'll talk about model monitoring a little bit later, but I think that often monitoring and evaluation is a little bit harder.
Mm.
So yeah, on a simple example, you can think of measuring accuracy of a classification model, saying like, is this a cat or dog? Is a common example. You can quickly go look at that model or some of the images and like get some ground truth data saying yes, it predicted it correctly or not.
Mm.
Um, but when it comes to like generating an image, how do you tell if an image is bad or wasn't what you
Right.
asked for, right? That's a much harder problem. It's also harder to kind of look at paragraphs of text and see if that's relevant to the question, if it has like the sentiment people wanted, the readability score. It's much more kind of ambiguous to get like, yes, this was good, or no, it wasn't. Obviously, you can build in feedback mechanisms like you might have seen in ChatGPT where users rate it up and down. But it does get kind of a lot harder, I think, for that. And you also typically might want to add in things like guardrails. If you're building let's say, a chatbot for a tax website or something like that, um, and people are asking it how to make sandwiches. Like
Mm.
maybe you want your chatbot to answer that, maybe not. Maybe it should only be related to tax information. So there's more kind of things to think about like that. Often also the models are pretty big if you're not just using an API. So how do you kind of handle that more maybe
Mm.
scalable infrastructure that you might need to like train and deploy that, which is what we already talked about, but maybe just at a bigger scale. So how do you scale up the GPU
Yeah.
clusters when you need them and scale them back down?
Okay. Okay. Nice.
And now we can go
So
to your new question.
yeah, yeah, I was getting to that. Yeah. Um, yeah, so it's not one person could handle everything when it comes to building a machine learning pipeline application or Gen AI application. I know at least in the big companies there are different people handling different stuff, MLEs, data scientists, analysts, engineers, and all that. But so do you see any lack of skills in different teams and companies when it comes to building these kind of applications, especially the large scale ones?
Lack of skills. Um, I mean, I think that when like the industry is rapidly changing,
Mm,
if you're building out kind of these full end-to-end applications, just from when I talk to people, of people putting models in production, often it's like you might not have done one of these phases as much before. So if you didn't know how to monitor a machine learning model or something,
mm,
not saying it's completely like something you can't learn. You can learn it. There's a lot of great companies doing really cool stuff now with it, and you can go take examples from them and put it into your pipeline. But I think, yeah, almost it's like, what are the MLOps best practices as a whole? And it's really
mm-hmm,
hard to answer because I feel like we're creating them right now, which is kind of a really exciting
mm,
place to be. So yeah, kind of if you've never done an end-to-end production pipeline before, it can seem really intimidating. Um, and again, like part of it's probably because they're still new, they're being created, they're changing all the time. Um, Definitely think of, like I mentioned, when you're building a machine learning application, it's not just training a model, putting it on production. It's kind of this whole life cycle piece. I think having that mindset from the start can be very helpful.
mm,
And yeah, just kind of learning, like for me, it was kind of harder coming from maybe just building machine learning models on some sort of cluster or in a Jupyter notebook or something like that, and then versus, how do I build like a scalable, reliable pipeline for
Mm-hmm.
these AI applications that can like scale up compute, scale it down. But a cool thing is that, there's so many different tools now in this space that's helping to fill all these gaps. So even if you don't have that specific skill, I feel like there's a lot of great people who have done a lot of work recently, and they're almost always happy to talk about it, like in the Slack channels of often these companies or open source projects building out these tools.
Mm-hmm.
Um, so yeah, I don't know. I almost want to say like just putting a whole pipeline together is maybe kind of a new thing for a lot of people in the field,
I bet.
especially now that more and more companies are actually putting some form of model in production, even if that's like an API.
Yeah, yeah, definitely. I mean, and anyway, for one person to learn all the skills, I don't know how feasible it is or sustainable it is, I guess.
Right, right,
But yeah,
right.
yeah.
Yeah, and I think there's, typically if you can, you want to have a whole team around it.
Mm-hmm.
Um, if not, you can look at tools to help augment the team or having a smaller team, which
Right.
is pretty cool that these things exist now.
Yeah, yeah. So when you are building or when you might have built like some of these pipelines in the past, what are some of the best practices that you would recommend other engineers and developers or data scientists to follow?
My philosophy that I think has been really helpful to me is put a model in production as fast as possible. And when I mean put it in production, I don't actually mean that maybe you're, put a model that you quickly made and it's not performing well and you're making business insights based off that or having it affect any user in any way. But I mean like creating kind of a bare minimum pipeline. And hopefully, if you can, if it's set up in your company, get it running on production data as fast as possible and kind of build out that life cycle that we talked about where you should be collecting new data anyway.
Mm-hmm.
So you should have the steps of like collecting data, training a model with that data, putting a model out in production, and then kind of continuing that life cycle with some sort of monitoring built in as well. But figure out like what that means in your use case. And again, it doesn't have to be the craziest thing ever at first, but having something that kind of replicates that life cycle, even if you change it in the future, I think is going to help you a lot. So build out the ML lifecycle loop kind of from the start. Like I said, even if it's pretty simple. And then with that, I think that you can select like a good orchestration tool or something like that. There's some other best practices that come in when I've talked to a lot of people kind of in the pipeline side that maybe they don't think about when they're choosing them for the first time. You should probably look at using a tool where that you can do local development. Kind of sounds
Mm,
obvious maybe, but some of the tools, if you set up a pipeline, every time you want to run and iterate on it, you might have to kick off like a cloud training job, and that can just take time and be harder to troubleshoot. So if you have
mm-hmm.
something where, let's say, most of the people I know work in Python, if they're doing stuff with machine learning models, um, if you can kind of do development with that locally, just to even maybe build a small workflow and get it tested before you kick off a really large cluster. You can catch a lot of errors way faster that way, and then you're not wasting those resources. Like at work, I have a pretty powerful M2 MacBook, and I
Mm-hmm.
think a lot of people do now. You can train PyTorch models on that
Mm,
decently well and do a lot of powerful stuff with data. So I think it like most people have pretty good hardware, so you should be able to do some form of local development.
got
Um,
it.
Building into, like I'd mentioned, caching into your pipeline as well when you need it can be a really useful thing. So, for example, let's say we have a really simple ML pipeline. You're downloading a data set, maybe you're doing some pre-processing to that data, and then you're training a model and evaluating that model. Well, if you want to rerun that whole workflow again and again because you're changing hyperparameters or something like that, you probably don't need to download that data set. And if you're not messing around with the pre-processing, you probably don't need to pre-process that data set again. Again, depending on your application, those could be pretty quick steps, or they might be pretty long steps if you have a lot of data. So you can enable caching and saying, if this didn't change, and I rerun this whole pipeline, but I change these hyperparameters, and I want to test this new version of a model, you can rerun that whole workflow, but take outputs that were from the last time you ran it. So you have this like cache artifact of this is the data set, this is the data set after it's pre-processed. Doesn't need to do all those steps again, and that can save you a lot of time and compute
Mm-hmm.
potentially as well. And then also I think people using type safety is a big one where for each task, you should define, the type of data you're expecting to come in and the type of data you're
Ah,
expecting to come out. um,
yeah, yeah.
it's like, it's a thing that you're kind of, it's not writing a full test for your task per se, but it's enough that you can catch a lot of errors that
Hmm.
maybe you weren't expecting. And also, it's funny, like, so Flight, the open source orchestration platform, it kind of requires you to write code this way. Like, you have to have types coming in and out of your workflows and your
Yeah.
tasks. Sometimes when people first like start onboarding, if they haven't been using typing in Python, there might be like, oh, a little bit of a learning curve. Like, I have to learn how to put types. It's not hard. You just say the type, like, if you're expecting integer, you put that coming in. If you're expecting integer out, you put that coming out. But sometimes it's just a little bit of friction because they're not used to writing that way. Once most people start writing like with types for Flight, and if they're writing Python code anywhere else, then typically they're going to kind of stick with typing. And it's obviously more and more popular. A lot of people listening to this probably are already using types in Python. Um, so that's one that can save you a lot of time potentially just on like catching little mistakes. I know it has for me in the past, or I've done things in the past where I wasn't using typing,
Hmm.
and then it took me a longer time to troubleshoot. I think I'd also mention containerization kind of on the task level versus like the whole workflow, where again you just want to use the specific compute when you need it. If you're using like A100s, for example, that can be pretty costly to like rent out from a cloud provider. Um, so instead of running your whole workflow with that, you're running that only when you need it on the training side instead of like doing all the other pre-processing. Versioning, people are probably already familiar with this with code. You use GitHub, right, to version every time you
Hmm.
make a change. This should be done with code, with the code, like you're probably already doing, but also that tied to like models and data and all the artifacts that come out of your machine learning pipeline. So there's different tools for this. Um, and then another thing that's pretty interesting that is a big cost saver when I've talked to people. This isn't always a best practice. It depends on what you're doing. But it is also using something like spot instances from AWS, which is where,
AWS, yeah.
yeah, like there's compute that's already up there.
Yep.
They'd rather kind of sell it for less. So someone uses it. And that can be a huge cost saver. Like, I forget the margins. I
Yeah.
like I feel like it's like 50% or sometimes
Yep.
90% or something cheaper, depending on what
Yeah.
you're looking for, which is kind of wild. You
Yes.
should also look at using that with like Chat GPT, or the GPT API has a batch
Mm.
processing mode now, where if you don't need an
Mm.
instance response, it can be like 50% cheaper by you sending a whole bunch of documents to it or something, and then maybe you're okay with it taking an hour or two to get back to you because you don't need an instant response. So look at stuff like that too. Like, if you don't need the real-time inference all the time,
Yeah.
there's a huge cost benefit of using something like batch processing, which is cool.
Hmm. Yeah, you mentioned that right. AWS Spot instance. It just took me back to the time when I was working as a data scientist and probably spent like 2 weeks just figuring out where the heck are we spending so much money on AWS. It's like, okay, what can I do? And then you mentioned the Spot instances. I'm like, yes, I've been there, done that. I have cried tears of pain, spending so much money on AWS instances. But yes, yes, this was almost like a ML Ops mini lecture for me. All the stuff that you just mentioned. I mean, I haven't been like so deep involved in the ML Ops side, like when it comes to production, deployment, or containerization. So listening to you, it was like, oh, mini lecture. Got it. This is cool.
And
uh,
sorry, and I think you asked a slightly different question before we went into um, some of these other ones, and then I interrupted you, and I went back to the Gen AI piece. But I think it was something like, what's the most intense to build
yeah, the part of the
kind of out,
pipeline.
yeah, out of the pipeline stuff that we talked. Um, and I'll just do a quick answer on that too, since I interrupted and I went backwards, and then they
No
um,
problem.
just like with most stuff in tech, it depends answer, which it's not always satisfying for everyone, but really depends on what your team has experience with, and how much data maybe is already available to you. So it depends on what you're building, what your team has experience with, because even just the data collection and understanding can be really challenging.
Mm, yeah.
Like, I've worked with companies a lot in like agriculture and healthcare and manufacturing, and just annotating that data can be really difficult, right? Like people always think, I just send off this data to, Mechanical Turk or something like that, where people go label it. But you often need an expert labeling some of the examples at first. If you're doing something with healthcare, people have trained a ton to learn what a certain tumor or something looks like. You can't just tell anyone to go label that. So often
Yeah,
you need
yeah.
like a domain expert as well.
Agreed, agreed.
And
Uh, yeah.
the deployment and latency can be pretty challenging. Again, it depends on your application. You might not always need that, but like quantizing models and getting to them to run on really tiny hardware with the accuracy you want can be really challenging. And then just kind of the pipeline as a whole. Like I think this ties into what we were talking about a couple of questions ago, where just having those skills of building a whole pipeline and this life cycle going back, that can be a challenge as well. But like I said, I think in a previous answer too, it's just like the great thing is like all of these are getting easier and easier like every year with all the tools and practices coming out now with people developing on them.
Nice. Thank you for sharing that. Now, I want to move on to, I think it's your favorite topic, and I'm very curious about it, is the ML monitoring. Can you explain what exactly is monitoring and why is it important in the life cycle of an AI project? It sounds like a very obvious question or rather obvious answer to this, but there are still, I feel like, information gaps with many people. So yeah, if you can tell us about that.
Yeah, I think ML monitoring is a really interesting thing. I've done a lot of talks on it before, and it's fun with like a live audience to ask, okay, like explain what ML monitoring is a little bit, and we'll talk about that more in a second. But typically, you're looking at data going into a model and, predictions coming out of your model, and you should be looking at those over time, probably, right, to make sure they're not varying or they're performing the way you think. And I explain that a little bit, and then say, cool, does like everyone think like monitoring your models in production sounds great, right? And everyone raises their hand.
Yeah.
And then I say, who is monitoring their models in production? And then there's not many hands up. So I think it is an area that's really important, really cool. Again, I think there's been a lot of adoption
Hmm.
increasing as well. But to kind of get back to like what is ML monitoring, it's kind of the process that you put in place for observing or measuring the behavior and performance of your ML models kind of after they're deployed. You can do some stuff before it's deployed too, or things like shadow deployment that we talked about. With large language models, you can actually use some of this like ML monitoring or AI observability piece in evaluations too. I think we'll maybe talk a little bit about that later. But that usually involves like collecting data on how the models perform over time and then detecting issues and then making adjustments as needed to maintain optimal performance. So a quick little, just one example of this is, let's say you have a pretty simple machine learning model in production. It's just taking tabular data going in, and then it's giving some sort of like classification result coming out. If you were monitoring a bare minimum, um, if you want to set up a bare minimum model monitoring system for that, I'd be looking at probably the data directly coming into the model, even though there might
Hmm.
be different parts in the pipeline that you could set up monitoring. But look at the data directly coming to the model and then the predictions coming out of the model. And basically, if you're looking at those over time, you can see like if something like data drift occurs, which is where the data really no longer matches what the model knows. So a common thing that you might do there is compare new data coming into the model to the um, spectrum of the training data set. And if it's way outside of what that looked like, chances are the model might not really know how to perform a right prediction on there. You can also be looking at the predictions coming out of the model, even if you don't have ground truth on that. Just looking at variations can tell you a lot. So if you, on a day-to-day basis, often have like 3 categories and the distribution of those categories is pretty evenly distributed for the classification model, maybe one day, all of a sudden, it's just one class the whole day. And you're like, whoa, what happened there? Like, that's not a typical thing. And so you can
Hmm.
just set up like a rolling window, even to say, like, if, the predictions vary way like a lot versus the other last 5 days or something, let's say, send an alert and then you can go troubleshoot and see what's going on with your model.
Awesome. Uh, Speaking of like tools, do you use any tools for monitoring? And if yes, which one?
Yeah, I know quite a few tools out there, and some of
Mm-hmm.
the other players like Datadog that have been in kind of the space of logging,
Mm-hmm.
not for ML specific applications in general, are building out, I think, really cool features from what I've seen. I haven't used them too extensively yet. I used to work at a company called Y Labs that is
Oh,
building
by
really
labs.
cool
Okay.
stuff still. They
Mm-hmm.
have an open source library called YLogs and one called Langkit. The way they work is kind of cool too, where the metrics for these are privacy preserving. So you're actually just kind of collecting summary statistics. So again, if it was a tabular use case, you'd get things like the min, the max, the mean, a
Mm.
few more little binning statistics, but you're not really sending raw data to the observatory like platform. If you wanted to use YLabs platform, it has like visualizations and makes it really easy to set up alerts and triggers and stuff like that. So again, if you detected data drift, you could use a trigger maybe to send off a data annotation job. So you could take that production data, send it to annotators. They could annotate it. You could then use that data to get ground truth for your model and see like what the accuracy score was and actually see if it was performing bad or not. And then you also have this annotated data. So now you can retrain your model with that new distribution of data. And then hopefully it's going to be performing better than it was for that
Got it.
distribution.
Awesome.
Another one I would also say check out is Arise. They're also doing
Arise. Yeah.
really cool stuff in the space, and I don't know if it's just the bubble I'm in from like working in the past and where I'm at right now, but I feel like Y Labs and Arise are often the ones I hear about the most. But there are other ones that you should definitely check out. Like I know like Fiddler is another name, Aporia, evidently. They're all building cool stuff, and you should look and see what tool fits your needs.
Mm-hmm. Got it. Yeah. Personal experience, I've definitely used Arise's Phoenix. It's pretty easy to use. Yeah, I would also recommend that one. Um,
And Phoenix
so
is for their large language model specifically, I
yes,
think,
that's
right?
that's for LLM evaluation and monitoring, correct? Yeah, it's actually a very good tool for sure. So, with all the tools you use, all the monitoring, I'm sure you get, and I think you also mentioned like the data drift and model drift, when it comes to like monitoring the whole pipeline. So, how do you handle these kind of issues in the monitoring process?
Yeah. So I think I'd mentioned you could implement monitoring in multiple places in your pipeline.
Mm-hmm.
So really, like you could put some sort of monitoring anywhere you think changes might occur in your pipeline. It could be good to catch them. Uh,
Mm-hmm.
but like I mentioned, at bare minimum, I'd suggest going with data going into the model, because if something did get messed up earlier in the pipeline, you're probably going to still see something wrong with your data. Whether you're monitoring for data drift or doing validation to make sure like your data is in a certain threshold or something like that, you're probably going to see that even if it goes through pre-processing um, in the data that goes directly into your model. And then you should get the predictions coming out of your model. And if you can get some ground truth potentially in the future, like I said, though, you can usually learn a lot even without the ground truth, like seeing the prediction variations and the data coming into your model. But the ground truth definitely gives you like, did your accuracy score change, etc. When you're starting out, you want to select where to measure. So it's an ML pipeline. Like we talked about all those different places, where you should measure. Like I said, could be directly going into the model. What you want to measure. So that could be something like data drift, where the data, again, looks different than the data did previously. When you're getting started with that, I think I'd mentioned you can just compare that data potentially to the training data set of the model. But
Mm-hmm.
sometimes you might want to compare it to another data set, like you'd have a golden metrics data set, or you could have a rolling window. So versus just looking at one stagnant data, you could be looking at the past month of data, the past week of data. It really depends on how your model's set up. So like if you're doing forecasting, that's a little bit different than doing classification, and your data is probably expected to look different over time. So you might want to do something like a rolling window versus comparing to like a static data set. And then you want to select which metrics to measure. So again, there's different drift metrics you can choose. You might also do validation metrics, like you could build something in saying if this tabular data set, it's always expected between the value is always expected to never be zero because I'm always measuring something, or it should never be a negative number. You can put in something saying it this should be never be a negative number, and if it is, something went wrong there and trigger
Mm-hmm.
an alert for you to go look at that data. And then you want to like I mentioned, kind of select how you want to compare that data over time, whether the rolling window or to like a static data set often. With generative AI stuff, like I said, it gets more challenging. You like my approach and how I've helped people in the past is usually kind of take a little bit of a shotgun approach with metrics sometimes at first. So like with YLogs or LaneKit, it gives you like something like 30 metrics out of the box. That's things like readability score, sentiment. You can add in custom metrics. So like there's pretty common ones that have had pretty good results, like I think Blue and Rouge, which help you kind of measure how relevant a text response was to a question.
Yeah.
You can start with all of those and see which ones are actually useful to you with data in production,
Hmm.
and then kind of take away metrics as you go if they're just noise later.
Got it. Got it. Do you think like the scores and just because I'm just curious, the blue and the rouge scores that you mentioned, do you think those metrics are fully reliable?
And I don't think most of them are fully reliable
Oh,
for generative stuff yet.
yeah,
Even
yeah.
another thing is like people using model as a judge, right? Or is that the term for it?
Oh
Where you're using
yeah, geez,
another
yeah.
LM as a
LLM as a
judge.
judge,
Yeah.
yeah, yeah.
With the generative AI stuff, like I was saying, there's no, at least from what I've seen, if someone knows if there's like a silver bullet for all of it, that'd be amazing. Let me know. But as far as I know, there's no perfect metric yet on it.
Yeah.
And so often if you're serious about it and measuring the stuff in production, it's using some sort of combination of kind of these
Mm.
things. Also, you might want to have stuff in place to monitor for specific patterns that show up in your data. So, for example, like PII, you don't want protected customer information leaking out of your
Mm.
model or
Hmm.
out of your RAG pipeline, right? Like
Right.
you might have prompts that you've made say never say this or whatever, but if people can trick it or it just does it sometimes anyway, because again LMs aren't always reliable either how they handle instructions. So I've actually had some stuff caught before where I was building like a chat bot for a online store kind of customer service
Okay.
type thing, and had a customer said they were angry with something and they weren't satisfied with it, with a product, and the LM made up a phone number for them to call, but it made it up like there wasn't a phone number given to it to call, and it
Oh
was
my
only caught
God.
because I was using YLabs for this, but it has something to detect these specific patterns like credit cards and phone numbers kind of built in, and so it said, hey, like yeah, out of this time frame, a phone number was given. And I was like, oh, that's weird. Like, why was it? And it just made it up. So,
Yeah, just
there's a lot of
made it
stuff
up.
like that that you might want to implement um, to make sure that either it's giving the correct phone number or it's not giving any phone number at all. Or if it does, you can step in and change those prompts or your RAG pipeline.
Understood. Wow, fake number, made up number, not fake number. That's so bizarre.
Right.
That's really funny.
But
Um, yeah. Okay. I have one more question, but this mini lecture is very interesting. I'll tell you that, and I'm going to call it mini lecture, I would say, because I am learning so much. Holy shit. Okay, but leaving you with the last question. Are there, rather, let me rephrase the question. What are some of the common misconceptions about ML AI monitoring that you would like to clear up for the interested folks?
common misconception is maybe that that you don't need it. I,
That one is a good one. I agree.
I, and I really think it does depend on your application that you're doing, right? Like you might not always need real-time monitoring. For example, if you're building like, I don't know, a fun application that doesn't matter if it's wrong and no one gets hurt with it and you're okay losing a person as a customer or something, like you don't actually
Yeah.
have any like money tied to it. Like you don't always need a really robust monitoring system for something like that. Though if you are serious about improving it, I think you gain a lot by, again, let's just going back to a large language model example, even um, extracting metrics or even logging the full result of like the prompts coming in from a user and the generative results tells you a lot about like how people are using your model over time. So again, like you might learn that the model that you made is really good at recipes or something like that, and that wasn't
Hmm.
originally your intent, but people are using it all the time for that. So maybe you should like double down and kind of pivot, the marketing for your model or something like that. So you learn a lot about like user behavior in there, and you should keep that in mind, not just about the model results and how the model is doing, but also like what are people doing with your model. If you're looking at those metrics, like if your model responded with a rude sentiment, you could also look, well, did the person ask a question in a really rude way or something like that,
Mm.
which is pretty interesting. But yeah, I think that I would evaluate, I guess, like what you need at a bare minimum of some sort of monitoring plan. And maybe it's not even using one of these tools, right? It was pretty
Yeah.
common, and probably still is pretty common for people to go in and like have logs of things and then go spot check, like, okay, what did that image coming in look like and what was the prediction out of it? If that's
Mm.
okay to you, because you're not losing money or customers that you actually need, and you're not actually like, harming anyone in the process, like maybe that's okay and you're just okay spot checking. But I would still come up with some sort of plan, like, look at it every day or something like that, even if you don't have something that captures these metrics. But I think with all these tools, capturing these metrics is way easier now. And if you just don't want to set up, you can do the other way. But now there's so many cool tools for you to grab. I'd recommend grabbing one and start the monitoring process. Even if you're just saving the logs and not using one of the really robust platforms, but you can be extracting those metrics, save them as a local log or as a log in your S3 bucket or something like that, and then compare those over time. So I guess I would plan for what is the worst that could happen if something went wrong with your model. And if it's really nothing bad at all for you or anyone else, then maybe you don't need something. Otherwise, I think I'd probably have some sort of ML monitoring built in or plan, like I mentioned. Unfortunately, it's common sometimes too, where monitoring or having that setup isn't really blocking anyone from having a model in production. So people go, well, I'll look at this later. I don't really need it right now. And then they actually have something in production that goes wrong and potentially cost them a lot of money. And it would have
Mm.
been way cheaper to have some sort of ML monitoring system built in the first place, and then they come back to it. So just keep that in mind.
I like how we started the answer to this question. Love it. Just.
Yeah.
But yeah, this was really great, Sage. Thank you so much for answering all these questions and giving examples and more. I had
Yeah.
a pleasure talking with you.
Thank you so much for having me on. This is fantastic.